Assalamu alaikum. We're going to start with exam style questions of chapter 2 describing motion. If you haven't completed and or watched those videos, make sure you go and check them out first before attempting these questions. Question number 1, use this graph for question 1 and 2. Okay, how is a constant velocity shown on the graph? So the graph we have over here is of speed time graph, and speed, the difference between speed and velocity is nothing but the only difference is the direction. That speed has no direction while velocity has the direction as well as the magnitude. Other than that, both of them works similarly. So they have asked how is a constant velocity shown on the graph, or we can say how is a constant speed shown on the graph. And we know that whenever there is constant, that means it's not changing. Not changing means that it is going to be horizontal. The sloping line at the start, no. The horizontal part of the line, yes. This part of the graph will be our answer. The area under the line, the area under the line is nothing but distance. The sloping line at the end, that also gives the variable or changeable speed on the graph. Question number 2, how is the distance traveled shown on the graph? As I mentioned earlier, that the area under the line will give us the distance, hence C is going to be the correct answer. Question number 3, a snail takes part in a snail race. The snail completes 180 centimeter course in 7 minutes. What is the approximate average speed of the snail? We all know the formula of average speed, that is distance over time, and we have distance that is 180 centimeter and the time that is in minutes, 7 minutes. So this is the time, and in the answers we have this meter per second. That means we need to convert meter and into seconds. So we need to convert centimeter by minutes, the one units we have, to meter per second. For that, what we are going to do is, if we have distance 180 centimeter, let's convert it into meters by dividing it by 100, right? So it's going to be 1.8 meters, and 7 minutes will be in seconds, will be, that means you need to multiply it by 60, and 7 into 6 will be 420, right? So other than that, for 20 seconds, now we will put these values into our main equation. That is average speed is distance over time. So that means that is going to be 1.8 divided by 420. And once we do so, we will get the final value as 0.00428 on our calculator for meter per second. So that is what the part answer as well has, 0.0043. Basically they rounded up the last digit to 8 is 2 is rounded off to 3. Question number 4, the velocity time graph shows the performance of a Formula 1 racing car as it accelerates from rest for 7.33 seconds and then brakes to a stop in 2.69 seconds. It covers a distance of 520 meters. What is the approximate maximum velocity? Okay, maximum velocity of the car. For this question, we need to see that this area is 520 meters. That means this entire area covers 520 meters, and the first 7.33 seconds are done, and then these are the rest of the 2.69 seconds. अब इसके अंदर उसने हमें ये कहा है कि आपको वेलोसिटी टाइम बताना है, और आपने ये जो मैक्सिमम पीक पॉइंट है आपने इसकी मुझे वैल्यू बतानी है, इसकी वेलोसिटी बतानी है. फॉर फाइंडिंग दैट वी नो कि अगर हमें डिस्टेंस पता है, हमें एक जो है उसका उसने हमें अगर डिस्टेंस दिया हुआ है, तो हम लोग उससे उस फॉर्मूला से हम लोग उसकी ये वेलोसिटी फाइंड कर सकते हैं, जो कि बेसिकली हाइट है ऑफ ट्रायंगल, अगर हम लोग इस ट्रायंगल को, ये फर्स्ट वाला ट्रायंगल देखें तो इसकी जो हाइट है वही हमारी वेलोसिटी आ रही है। सो 1/2 इंटू बेस जो है वो हमारी, अगर हम लोग ये फर्स्ट वाला ट्रायंगल कंसिडर कर रहे हैं तो उसके अंदर, ये फर्स्ट वाला ट्रायंगल, तो इसके अंदर हमारे पास 7.33 सेकेंड उसने पहले चलाया, तो 7.33 हमारी बेस हो गई। और उसको जब हम हाइट से मल्टीप्लाई करें जो कि वेलोसिटी होगी, तो हम उसको एच ही रहने देते हैं फॉर द टाइम बीइंग, and the rest of it plus half, because this triangle is also the part of the entire distance that this car has occurred, has performed, has passed. So the base will be this much, that is 2.69 seconds, 2.69 seconds, and multiply with the height, and the height is the velocity, so h as well, and that is equal to 520. So if we take common from the very first equation that we have formed, इसमें से अगर हम लोग common लेंगे, we will take 1/2h as common, and then 7.233 will be added, 2.69 is equals to 520. Now we can just add it up. 1/2h will be, when added 7.33 plus 2.69, it will give us 10.02 is equals to 520. And now we are going to make h the subject. 520 multiply by 2, firstly multiply by 2, and then we are going to divide it by 10.02. By doing so, we will get the value 103.79, which is almost close and near to 105 meter per second, and that will be our maximum velocity of the car. So basically what we did, and what the question asked was that there is a velocity time graph and it accelerates for 7.33 seconds, and then it take a break and come to a stop at 2.69 seconds. The entire distance was covered was 520 meters, and we know the area under graph of the velocity time graph is distance. So this was the distance. So the triangle 1 plus triangle 2 is equals to total distance. That is the formula we applied over here. This is about, this particular one is for triangle 1, and this one is about triangle 2. And then this is the total distance, and we just made h the subject to get the h is basically the height, and height is basically the velocity, the maximum velocity of the car. So that is how we got the value of h, which is 105 meter per second. Let's continue, and we can see question number 5. The table shows Usain Bolt's split times from his world record 100-meter run in Berlin. Okay, each split time is for a 10-meter section with a section of the 100-meter distance. The time for the first 10 meter includes his reaction time of 0.146 seconds as well. Reaction time is something which is caused by human error, or it's something that is very natural. Whenever you start to do something and you tend to take a reaction time, a response time, that is what it is, and it's a very minimal error that is mentioned over here to reduce the problem and improve the accuracy before he left his block. Okay, so calculate the time that Usain Bolt takes to run the first 10 meters from the moment he starts moving. Reaction time is 0.146, and our time of first 10 meters is 1.89. That means जब उसने पहले 10 मीटर जब उसने चले तो उसके अंदर उसको 0.146 जो सेकेंड्स हैं ये उसके रिएक्शन में लगे प्लस दिस टाइम, तो टोटल टाइम हमारा ये लगा। तो अगर हम लोग उसमें से रिएक्शन उसका उसे मूविंग वाला लिखें तो हम लोग 1.89 में से 0.146 जो रिएक्शन टाइम है हम उसको उसमें से माइनस कर देंगे टू गेट आवर एक्चुअल आंसर, दैट इज गोइंग टू बी 1.89। 1.744 सेकेंड्स। ये वो टाइम है जब वो निकल गया, मूव करना स्टार्ट कर गया, और वो जो रन कर रहा था उसको इतना टाइम लगा। और जो 0.146 सेकेंड था ये उसका रिएक्शन टाइम था। तो उस रिएक्शन टाइम को हमने यहाँ से टोटल जो टाइम उसे 10 मीटर ट्रैवल करने में लगाया उसमें से माइनस कर देंगे। बी पार्ट में उसने कहा है कैलकुलेट उसैन बोल्ट्स एवरेज स्पीड ओवर द फर्स्ट 10 मीटर्स फ्रॉम द मोमेंट ही स्टार्ट्स मूविंग। फ्रॉम द मोमेंट ही स्टार्ट्स मूविंग इसका मतलब है कि हमने टाइम अभी भी 1.744 ही यूज करना है। अब उसने कहा है स्पीड, एवरेज स्पीड फॉर बी पार्ट। स्पीड का क्या फॉर्मूला होता है हमारे पास, डिस्टेंस ओवर टाइम, means we have 10 over 1.744, and when we do that 10.1744 we get the value of 5.73. and what units are we going to use, meter per second, so meter per second. For C part, calculate Usain Bolt's maximum speed over the first 10 meters, ignore his reaction time and assume his acceleration is constant. So we need to find its maximum speed. Maximum speed आप तभी करते हो जब आप किसी दो चीज़ों को compare कर रहे होते हो. So what we can do is we can double the distance, right? So V is equal to 2 into, like we are multiplying it twice ताकि हमारे पास आ जाए maximum speed. So 2 इंटू डिस्टेंस हमारा कितना कवर हुआ, मैक्सिमम हमारा जो डिस्टेंस है वो 10 मीटर्स है, और जो हमारे पास टाइम है उसने कहा इग्नोर हिज रिएक्शन टाइम, सो वी आर गोइंग टू यूज 1.89 इंस्टेड ऑफ 1.744, so 1.89 and we will get 20 over 1.89, that will give us 10.582 10.58 meter per second as our answer. Okay. For D part, calculate Usain Bolt's acceleration over the first 10 meters, ignore his reaction time and assume his acceleration is constant. So now we have to use acceleration formula. We know acceleration's formula is A is equal to V minus U over T. So for finding acceleration, we know कि वो start जब किया उसने तब वो stop था, बिल्कुल जब रेस में उसने शुरू करने से पहले वो 0 मीटर पे 0 सेकेंड्स पे था, अभी वो रेस्ट पे था. So that means our initial speed is going to be 0. So V minus 0 over T, or we can also say A is equal to V over T. V हमने अभी पिछले पार्ट में निकाली 10.58 मीटर पर सेकेंड, और टाइम जो है उसने कहा है कि रिएक्शन टाइम को इग्नोर करना है और आपने स्टार्टिंग वाला 10 का बताना है, दैट मीन्स 1.89 हमने टाइम लेना है. सो when we will divide this 10.58 with 1.89 we will get 5.59, or we can also say 5.60 मीटर पर सेकेंड स्क्वायर, क्योंकि ये एक्सेलरेशन है और एक्सेलरेशन में नीचे स्क्वायर आता है, मीटर पर सेकेंड स्क्वायर. कैलकुलेट उसेन बोल्ट्स टॉप स्पीड इन द रेस. टॉप स्पीड अब निकालनी है. वी कैन सी कि ये हमारे पास मीटर में सारे डिस्टेंसेस हैं जो कि 10-10 के इंटरवल्स हैं. ये सारों में इंटरवल्स का जो चेंज है वो 10-10 के साथ कॉन्टिन्यूसली हो रहा है. सो वी कैन सी ये मीटर्स है हमारे पास, सारे डिस्टेंस हैं, और ये सारे हमारे पास टाइम है. और अब हमने स्पीड निकालनी है. स्पीड का फॉर्मूला क्या है, डिस्टेंस ओवर टाइम. और अगर हमने मैक्सिमम स्पीड निकालनी है, मैक्सिमम स्पीड निकालनी है इसका क्या मतलब है, जिसमें सबसे कम टाइम लग रहा होगा. तो सबसे कम टाइम किस वाले में लग रहा है, इसमें हमारे पास 1.744 लग रहा था, इसमें 0.99 जो कि डेफिनेटली इससे छोटा है, 0.90 इससे छोटा है, 86 इससे छोटा है, 83 फिर छोटा है, 82 81 और भी छोटा है, 82 फिर से ज़्यादा बढ़ गया. दैट मीन्स 0.81 जो है ये हमारे पास लोवेस्ट टाइम है, क्योंकि हमें पता है ड्यू टू इनवर्स रिलेशन कि अगर इफ वी हैव स्पीड ओवर हियर एंड डिस्टेंस एंड टाइम ओवर हियर, जैसे जितनी हमारी स्पीड कम होगी उतनी स्पीड ज़्यादा होगी, जितना टका होगा उतनी स्पीड ज़्यादा होगी, जितना डिस्टेंस ज़्यादा होगा उतनी स्पीड ज़्यादा होगी. ये डायरेक्ट रिलेशन के अंदर है. सो क्योंकि डिनोमिनेटर जितना छोटा होता है उतनी वैल्यू बड़ी होती है, तो टाइम जितना थोड़ा होगा उतनी वैल्यू यानी कि स्पीड बड़ी होगी. तो हमारे पास 0.81 जो है यहाँ पर ये सबसे छोटा है. इसका मतलब है कि जो ये वाला सेक्शन है इस सेक्शन के अंदर हमारी जो भी वैल्यू आएगी दैट इज गोइंग टू बी द स्मॉलेस्ट. सो लेट्स सी, वी कैन से स्पीड जो हम लोग निकाल रहे होंगे वो किस तरह से निकालेंगे, क्योंकि यहाँ पे भी 10 मीटर्स का इंटरवल है. सो वी विल से distance 10 over time 0.81, and we will write it answer 0.8 10 divided by 0.81 is going to be 12.34 मीटर पर सेकेंड इज द लार्जेस्ट स्पीड. क्योंकि अगर हम कोई भी और स्पीड लेट्स से हम अगर ये वाली कैलकुलेट करते हैं, इट ऑल्सो हैज 10 on the in the numerator. Let's do this over here. 10 divided by 0.9. If we do this, we are getting the value of 11.11. That means कि हमारे पास जो आंसर आ रहा है वो 12.34 से छोटा आ रहा है. इसके अलावा हम कोई भी वैल्यू यूज कर लेंगे तो हमें जो ये वैल्यू है सिर्फ इसमें सबसे लार्जेस्ट मिलेगी. Let's move on to question number 6. Question number 6. An aircraft happened to be flying near a volcano when it erupted. The co-pilot took some video footage. He handed the footage over to scientists, and then scientists used this frame and all of that. So plot a graph for the position of the boulder at interval of 5 seconds. Plot the vertical height of the boulder vertical axis against the horizontal axis. So ये vertical height और horizontal height है. इसके ऊपर अब हमने एक graph बनाना है. Let's make it over here. Alright, so this is the graph that I have made. This is just the labeling that I did. I started 5 because I can see the values that start from 500 till it goes with 3150. That is a horizontal distance, so I kept it till 3500. And for the vertical height, I can see that it is definitely starting from 500 and then going with 4500 and more. So for 4420 is the maximum one here. So इसके हिसाब से सारी रेंज रखी है. ऑल ऑफ द स्केल इज वेरी इक्वल. 500 के गैप के साथ सारे इंटरवल्स के साथ यहाँ पे वाई एक्सिस में भी 500 का गैप है और एक्स एक्सिस में भी 500 का गैप है. एंड देन आई लेबल्ड हॉरिजॉन्टल डिस्टेंस ऑफ बोल्डर जो कि है यहाँ पर, जो कि इंडिपेंडेंट क्वांटिटी है जो कि वो यहाँ पर है, और जो डिपेंडेंट क्वांटिटी है वो हमने यहाँ पर वर्टिकल हाइट जो है या जो हमारे पास वाई एक्सिस में है जो हमने वैल्यू यहाँ पर लिखी हुई है. ठीक है. नाउ वी आर गोइंग टू जस्ट प्लॉट द वैल्यूज. एट टाइम 0 द हॉरिजॉन्टल डिस्टेंस ट्रेवल्ड is 0 and the vertical height is 4420. That means at 0 and 0 the vertical height, let's go with another color, let's take purple. Okay, and the value is going to be somewhere between 4000 and 4500 and near to 4500 because it's 44, right? So it's going to be somewhere over here. After that we have done this. At time we have 525 meters. 525 meters, somewhere it's going to be around here at this position, somewhere over here. And then we will have the vertical height 4292, so that's going to be somewhere over here. So it's going to be like this. Okay, after that you are going you can, when you will have a graph page, it will be easier to track because you can see यहाँ पे 525 मिड में कहीं आ रहा होगा और यहाँ पे 4000 4200 4000 के करीब थोड़ा सा होगा. देन वी हैव 1050 बिल्कुल 1000 के करीब होगा. यहाँ पे 1100 और इसके यहाँ पे दरमियान होगा 1050 और 3924 जो है वो बिल्कुल 4000 के करीब होगा. सो द वैल्यू इज गोइंग टू बी समवेयर ओवर here. Then we have 1580 जो कि यहाँ पर बन रहा होगा y x एक्सिस पे, और 3311 जो है वो हमारे पास इस तरफ बन रहा होगा for in the y axis. And when we will join those points from the scale, we can see is somewhere over here बन रहा है, इधर से कुछ बन रहा है. Then we have 2100 which will be over here, and then 2453 which will be over here. So the connected point is going to be like this. 1349, that is going to be over somewhere over here. So if we connect them those points, it's going to be over here, somewhere over here. इसको थोड़ा सा मैंने dark point किया है. Just make sure that you are pointing it with a sharp pencil. So it's going to be over here. Lastly हमारे पास 3150 है y axis पे, x axis पे, जो कि इधर होगा और उसके पॉइंट भी यही रहेगा क्योंकि वो 0 जो है 0 के ऊपर है, तो वर्टिकल हाइट हमारी 0 है. So the line is going to be, the shape of line is going to be something like this. Okay, explain the shape of the graph. So explaining the shape of the graph, so this was the vertical height and this was the horizontal distance. So we are going to explain it that the boulder is moving at a constant speed in the horizontal direction, because basically what it is doing is it is going further away, so it is increasing the horizontal distance, and it is also decreasing the vertical height gradually. So we can say boulder is moving at a constant speed horizontally while accelerating vertically, because you can look at the tangents. The tangents are gradually increasing, because this is going to be the maximum value, because our gradient is almost vertical. So that's what we can see from this graph. Okay, I think this is the last few parts. See, the scientists thought the aircraft had been an altitude height of 4420 meters when the video was taken, but it was 3600 meters. Use your graph to estimate the horizontal distance the boulder will have traveled from the point that it was recorded on the video where it hit the ground. So let's see. We can see उसने कहा है कि originally वो 4420 यहाँ पर था, और but it realized कि उसके अंदर से 3600 जो है, it was actually 3600 meters. So that means we need to subtract 4420 minus 3600, by which we will get the value of 820 meters. So we are going to look at 820 meters over here. This is going to be 820 meters, and we can see कि ये कहाँ पर lie कर रहा है, going somewhere between 2500 and 3000. So we can approximate the answer. If we are using the graph, we can give a better answer, but as we are approximating, so the answer is lying between 2500 to 3000. So we can just keep it an average of this number by actually adding both of them. 2500 plus 3000, it's middle part, so that will give us 5500, and 5500 divided by 2 is going to be 2750. So the horizontal distance is going to be 2750 meters. Use your graph to estimate how long it took the boulder to hit the ground from where it was filmed. So we can see that it approximately took 25 seconds, and then it fell, that is 30 seconds. So it took a few seconds over here and a few over here, so we can see it approximately took 30 seconds. Calculate the horizontal speed of the boulder. Further finding the horizontal speed, we are going to take the total distance, and that is the total distance of the horizontal is 3150 divided by 30, because that's the value we have for our time. 3150 divided by 30. As we are finding speed is distance over time, so 3150 is the distance of the horizontal boulder, and 30 is the time, so the answer is going to be 105 meter per second. Suggest why there is ash and rocks over a wide area and not just a circle of debris, that your answer to C might be correct. So we can say that rock and dust will be having multiple angles, multiple speeds, and we cannot have a constant dust or ash or rocks of debris. So these dust will have effect more by other frictions than the solid rock. So as there will be more surface area, right? So that's going to be our answer, that rock and debris or in dust will have much more speed as has more or greater surface area than rocks. Than rocks, yeah, or solid rocks. So this is where this question ends and the entire chapter 2 as well. I hope this session was a little helpful.